So in the previous two videos, we've gotten the resistors, the LEDs, the switches, and the sockets mounted. And we're going to move on now to the next round of parts. So we're down to the 7805 regulator, which is this guy right here. It's just a standard 5-volt regulator. You know, they show it can be mounted flush to the board. Let me check the lead spacing and see if this one will actually mount flush to the board. Again, getting it mounted up, it's going to be a little tight. I don't know if this will show up or not. The leads get wider up towards the package, and sometimes that wide area is shorter or longer. Bending these right where the knee is, where the short goes to the long, and having it line up on the little screw hole there would leave the leads in the wrong position. However, I think I can bend those in the middle of the knee, about there, still have it mount down flush, or not in the middle of the knee, more towards the package from the knee. Still have it mount flush. And then I'll actually dig out a little nut and bolt from my hardware collection and just make sure this is solidly up against the PCB. And we'll go from there. Oh, that's pretty close. I actually think I'm gonna screw that down on the board. Here's just a random box of hardware from things I have recently disassembled. Let's see if we can find a screw and a matching nut that work together. Maybe. That doesn't seem to be the right nut. This is just really just a big random mix of stuff that's just kind of accumulated. Okay, that's a match set. Screw head will come through the board from this direction. Get the little nut started on there. And find a little Phillips. I'm sure there's one laying around here lost in the mess someplace. And torque that up. That's a flat. I don't think it'll fit in there. It might. It's got a pretty fine head to it. Oh, it fits in just fine. Just kind of hold the package a little squarer. Put a bit of torque on that and we're good. That head's lower than the body of the switches, so having that screw there shouldn't be a problem. You can hear the neighbor's dogs howling over there. Every Saturday she takes off to go someplace and her dogs howl for a while. Not that I mind, I really don't. So this of course is going to get soldered on the front side of the board. Center leads the ground one. It's attached to the metal on the back of the 7805 and all the way up to that screw and nut we just put on there. So there's, in that middle pin, there's a fair amount of thermal mass behind it, which might make soldering it a little bit difficult. And that fly is back. We'll see where it might just solder up just fine on its own, and it did. Solder joints look okay. Get these lids, or these leads, cut. We've got the voltage regulator in place, mounted as shown on the board. There's two capacitors in here. There's a little disc, and there's an electrolytic. Ceramic capacitor goes in C2. It is a ceramic disc. It's not polarized, so orientation doesn't matter. It fits just fine. The electrolytic here, however, is polarized. They usually have a marking that indicates the negative lead, and the longer pin's the positive, like on the LEDs. There is negative indicated here on the board. So it does look like it goes in this orientation. He does leave it standing up. I will kind of follow the same process you've seen all along. We'll solder one pin, reheat it, make sure the capacitor is down flush, solder the other pin. And call it good. Ceramic looks square there. These 3-pin voltage regulators are much more stable than they used to be. With the really early ones, and we're talking decades ago, they would oscillate if they didn't have kind of the correct capacitance on the input and output. That's not nearly as much a problem as it used to be. We've got the the electrolytics on the 9-volt input to filter it. There's a little 0.1 here just to help deal with current spikes. In the digital electronics, we have a little CAN oscillator. I saw it here. It is labeled 16.0. In this case, it can go in either direction. It's not polarized, but I'm going to put it in the orientation so this way the text is actually up on him. It's just kind of a personal preference. Again, doesn't really matter. We'll follow the same process here. One lead, heat, press up flush, and then the other lead. Assuming I can get that lead to solder. He's nice and flush. Didn't see anything here about any kind of spacer beneath him. Sometimes when there's tracks in a PC board under a metal can like this, there might be a little nylon spacer you fit in there, just to keep it from shorting. In this case, it's not a big issue. Like I said, there was no indication of needing that here. Orientation is not important. In this photo, he already shows the 4-pin header in for the RTC. So we don't have that 4-pin header in yet for the RTC. And I'm not sure what this header here is for. Headers on this side of the board. I'm just going to solder one pin, and I'll push it in square and flush, and then solder the rest. Same loop you've seen me going through time after time here. While you do this, you want to be careful not to put your finger on the pin you're heating. It does get hot and burn you. It doesn't look square to me, and I'm not sure why. So we'll try again. That looks square and flush. Well, I'm having a hard time getting solder to flow on those pins. So we've got the header in place. I keep catching my elbow on the blue tape that we used in the previous video. At this point, I'm not actually going to put the ICs in because I want to make sure the 7805 regulator is producing 5 volts before I put the chips in. A little divergence from the assembly instructions, but that is kind of the way I prefer to do it. I also think I'm going to do a couple of things different here as well. Again, it's very much personal preference. We've got the DC input jack and his little nut that holds him in place, and everything else here looks to be hardware. So I'll kind of move out of the place. I think I'm going to, apologies for stepping out of the video here for a second. I'm going to go dig for a few things. Does fit over there. Okay. I'm going to set this up so that I can plug the power on and off the board. And I'm going to do that. I'm going to polarize it at the same time. So this will be a little bit of a cheat here. There's a little 4-pin. 4 pins all I've got, so what I'm gonna, let's see, sizing how that'll work. 3-pin would be better. Do I have a 3-pin cable? Actually, there's even a better way to do this if I have a 3-pin cable. Let me look at my jumpers and see if I have a 3-pin. I think all I have are 2 and 4s in the box here. Well, apologies for being off camera. Let me do a bit of digging here, looking for a little bit of storage container I have that I rarely ever look at. Hopefully it'll turn up here. Never find what I'm looking for. Apologies for the silence there for a minute. I'll keep digging here and see if I can find what I want. Nothing here is ever easy to find because there's so much of it. And there's what I'm looking for. I do have some 3-pin ones. So I'm going to do a bit of a cheat here. I've actually got a 3-pin connector. I'm going to steal the leads out of here. Get the better glasses on. There's a little release pin that if you can pick it up, the crimped on wire end will come out. If I can do this. always a little bit tricky to do. Come on, there it goes. There's one. Two. And three. I'm going to load those into the little 3-pin carrier here. And you'll see why in a minute why I'm going with 3 pins. I'm going to trim this little header down to 3 pins. I'm going to take one of the end pins and I'm going to cut it off here. I'll only be soldering the 2 pins that go through the board. This 3rd pin won't be soldered, it'll just be carried along here in the little header. We'll catch him if we can keep him in place. Bit of tape to just kind of hold him in there. Same thing, I'll tack 1 pin, push him in flush, tack the other pin, and he will be in there flush. Tip looks really dirty. Now he's obviously not flush, but that's okay because we're going to do this. Hopefully I've got that square and flush, and it looks good. Come on. Oh, well, man, that's Nemo. So what's going to happen here is you're going to be able to put this power connector on either orientation, which seems like it would be a problem. But what I'm going to do is the center pin is the negative. So the center pin, or the center wire here, will go to the negative on the connector, and then I'll hook the other 2 wires together to the positive. And that way, whichever orientation you put it on, it's still got power come correctly to the board. This will just make disassembling it a little bit easier if I ever want to tear it down, and putting it back together a little easier. And let's look at the wiring here and just make sure I have that correct. So, did I cover up the silk screen? Yeah, ground is marked as the center pin. So what I'm going to want to do now is trim this back, trim these back about the same length. I'm going to take the purple and the blue, the outer ones, and I'm going to twist the ends together out here. And that'll bring the +9 out to the 2 outside pins. The ground will be in the middle. With ground in the middle, if I put it on this way, I've got the +9 on the purple wire coming into the board. If I put it on this way, I've got the +9 coming in on the blue wire, and that way the orientation just doesn't matter. Because the 3-pin will go through the nut for this. Let me grab the case here and make sure the 3-pin will pass through, and it will. I can pre-build this up, install it in the case when I'm ready, and go from there. So the next thing I need is a little bit of heat shrink tubing, just to make sure this is a clean build. I've got some heat shrink tubing here. See if I can find some appropriate lengths. And diameters. Get a couple pieces here of about the same length. They don't need to be terribly long. It'll just make for a little neater build. picture with it in this orientation. Ground is that guy right there. Ground in this case is the gray wire. It's these little details like this when you're doing a build that to me make all the difference, from kind of a haphazard, let's just get it together and watch it work, versus let's actually do a nice build. If I can get this oriented in a way I can get the soldering pencil to it without it moving around too much. You can see what I'm up against here. I really need the third hand for this, I think. That stupid fly is going to make me crazy. Okay, that doesn't look too bad. We'll solder that. Heat shrink tubing still on there. Good. I suddenly was fearful it had fallen off. Get the second piece of heat shrink over these two leads, if it'll go over them. Okay, it's a little too small a diameter to fit over them. So we'll get a little bit bigger piece here. Again, not super worried about the color here. Unused, and the V plus goes to the L-shaped one there. Comes up through there. Again, I'll just kind of hold that in place. We'll get that soldered up. Oh, you stupid fly. Can't put a lot of pressure on that. It's just barely being held in place here. Trim the extra wire out of there. That guy. And that guy. Shrink tubing. One more look. The center wire is to the ground. These two wires are to the plus. Get the heat gun here. Oh, I've got the wrong glasses on for this. Plug that in. Get the better glasses. This guy a minute to heat up here. Apologies for the noise. This will take a second to heat up. Again, apologies for the noise. Shrink that tubing down. Side to cool here. And again, the nut will go over easily, so this can be mounted. This whole assembly will go through the case just nice and clean. Happy with that. This guy can go on either orientation, it just doesn't matter, and the board is still powered up and protected. Although if I was to do that, offset a pin, I would get the power on the board backwards, but that's why we have really 3 pins there. So the next thing I want to do here is check out the little 9-volt adapter, make sure it works. Let me check the camera. I haven't checked it for a minute. We're getting up towards 30 minutes. Get a couple of better leads here on the meter. I'm going to go to DC 40 volts. And hopefully we've got 9 volts on this little guy. Hopefully you can see the meter there. 9.4, that's perfectly fine. Hook him up. Bring power to the board. I'm going to assume that the TTL devices on here are standard pinouts. So let me spin this around. Oh, come on, leads. I'm going to kind of spin this around. So according to the silk screen, I've got pin 1, the socket here. In this case, pin 8 is going to be ground. Pin 16 should be VCC. Let me get the meter in view here. We would expect to see 5 volts there. And we do. Would expect to see 5 volts in the same place on this socket and on this socket. And I don't know the pin out of the 18 mega here. I have no idea what the pin out is, so really can't check the corners, but this tells me the 7805 is working. You know, we've got 5 volts coming out of it. It's the right polarity. I feel good about being able to plug in the chips now and not damage anything. If we take this connector and flip it around, we'll end up with the exact same thing. Again, plus 5 volts. So by going to 3 pins, I've created polarity. You know, polarity doesn't matter as long as it, you know, it's 3 female to 3 male pins. So we've moved that piece forward nicely. Oh shit, did I put that on the wrong side of the board? I put that on the wrong side of the board. Ha! You watched me do it. Now let's remove it and flip it around to the right side of the board, and we'll do that in this video. So yeah, this needs to come off the back of the board, not the front of the board, or it won't fit in the case. That was kind of stupid, but you know, if you don't make at least one assembly error, you're doing something wrong. This guy's going to take a bit to get up to temp here. Starting to get there. I want to give it enough time to get up to temp. I want the solder to pretty much instantly melt. And we will attempt to unsolder these 2 pins. Pull him out. Flip him over to the correct side of the board. Basically, I was being stupid there, not paying attention. I've harped on a couple times it's a double-sided load. Need to pay a bit of attention. He, of course, shifted around there a whole bunch as I soldered. Let me get him back in flush. He's square. Easy enough fix. And again, I'm confident this is going to be fine. The power cable has plenty of clearance to go on either orientation. It's not like this is going to get connected on and off a lot. That 3rd pin is just floating there, but it's being held by the plastic carrier. So that really, I think, gets us do a point here where I'll break the video again. We're probably about a half hour again. We still got to mount the RTC, put the chips in, get it in the case. But I'll wrap this piece up here, and we'll pick it up in the next video.